So good morning, all my beloved students. Previously, I have explained the Unit 2 in your dairy technology syllabus, that is the utilization of different equipments and also the sanitation process. And I have previously explained the pasteurization process. Now today, I will explain basically the homogenization process. Both are very important in every industry, every dairy industry, because homogenizer and pasteurizer is the heart of the industry. Okay, so first of all, you have to know what is the homogenizer or what is the homogenization process. So basically, homogenization name says that homogenizer means uniform size. So according to United States, homogenizer milk is a milk which has been treated in such a manner as to ensure breakup of the fat globules to such an extent that after 48 hours, storage no visible cream separations occurs on the milk, and the fat percentage on the milk in the top 100 ml of milk. Basically, homogeneous means the fat globule is the largest size in the milk. So if we by the homogenizer process, these fat globules are uniform in size. That's why homogenizer is required among this process called a homogenization. So here is basically primary homogenization and secondary homogenization process. So when the emulsion is created directly from separate liquids is called primary, and when the emulsion is created by the reduction in size of droplet in an existing emulsion is called secondary. So basically, homogenization is achieved by a mechanical device called the homogenizer. An application, basically homogeneous process basically applied here in the milk industry, also beverage industry. Okay, so it is normally processed by standardizations, the mixing of several different milking hard and dairies to produce a more consistent raw milk prior to processing, and to prevent, reduce and delay natural separation of cream from the rest of the emulsion. Basically, if we see the in every dairy industry, first of all, when milk is arrived or receiving the milk, then it is clarifier or filtration process, then pasteurization, then homogenization. This is the steps. Okay. Another application, the fat milk normally separated from the water and collects on the top. Homogenization breaks the fat into smaller size, so is no longer separate, allowing the scale of non-separating milk at any fat specification. Now the methods. Basically here different type of methods I have explained here. So first of all, milk homogenization is accompanied by mixing massive amount of harvested milk to create a constant, then forcing the milk in a high pressure through a small holes. Okay. Now another methods of homogenization like a extruder, hammer mill, colloidal mill to mill solids. Milk homogenizer is an essential tool of the milk food industry to prevent creating various level of flavor and fat concentration. Now, a homogenizer is a piece of laboratory or industrial equipment used to the homogenization of various types of materials such as tissue, foods, plants, soil, etc., where we can use the homogenizer. Now, basic parts of the homogenizer, basically previously at least 1000 years ago, the motor and pestle were used for this purpose. Now, modern scenario, that is the bead mills, rotors, starter mechanical, ultrasonic treatment, high pressure, etc. Now, mechanical homogenizers. Here, if we see the structure or pictures, you can see that where feed is poured on the top of the machines. Here, then sheet, impact ring, and homogeneous product is outer part. Okay, or outlet. Now, here different parts, that is the cell laser, high shear mixer, polytron, disperser, homogenizer, rotor starter homogenizer, tissue titrator, etc. here presents. Another homogenizer is high pressure homogenizers. High pressure homogenizers are developed approximately 100 years ago during the industrialization. The basic idea of combine is a high pressure pump, disruption systems, pairs, and enducers. Okay, this is the pictures. And ongoing develops on the pumps and valves motivate either by daily application problem or new product challenges. Current technique, that is the volume streams, that is the Europe, and pressure United States, both are comply and apply this the process. Homogeneous pressures is industrial application today in the range of 50 to 2000 bars. We are all know that is the two-stage homogenizers where we can apply pressures, okay, first stage and second stage, and this pressure is also divided by two forms. Now, limitation of the homogenizers. With the variety of applications of homogenizers, there is also a list of products that this method would not be appropriately paired with. The homogenization process causes a reduction of particle size in liquid. It would not effectively produce solid food or those comprised of large particles. It uses force as opposed to thermal actions. Homogenization does not sterilize the foods or beverages, so the must be done through a separate process. Homogenization has a low energy efficiency, meaning that nearly half the energy is lost at heat is some emulsion or disruption formulations. Now, the advantage and disadvantage of the process. Advantage is that it prevents removal of fat or cream from milk. Homogenized milk results in softer curd and therefore easily digested by infants. Churning of fat does not occur during the bulk transportations. Fat is uniformly distributed and therefore gives uniform consistency. Homogenized milk is comparatively resistant to development of oxidizing flavor defect. Disadvantage: homogenization offer possibility of incorporation of frozen fat into milk. Homogenized milk is prone to development of sunlight or activated flavor defects. Homogenized milk is returned unsold from the market is difficult to slaves a centrifugal separation of fat is not possible. Now, another part, that is the filtration and clarifications. So when milk is receiving at the dairy docks, first of all filtration is done or clarification, both are same, okay. So in our daily house, when in our home, when we collect the milk, basically we are filtered by by the milk, and then we can heated it, okay. So and this is the same process in the industry. So filtration and clarification basically refers to making the milk passes through a filter cloth or a filter pad. The filtering medium has a pore size, basically this is called a mesh size, 25 to 100 millimeters, that permits most of the foreign matters to be retained on it. The milk filters consist of a nylon filter bag or a filter pad supported on a perforated stainless steel supported held in a SS enclosure with a tight fitting lid, milk distributors and inlet and outlet connections, okay. So now the clarification, this is the almost same of the filtration process, but where we use basically clarification done when milk is produced skim milk powders. We all know milk content fat percent basically around 4% fat, but in skim milk powders there is no fat, basically 0.5% fats. So we have to, when we produce the skim milk powders, so first of all you have to remove the fat, then you can use the spreader, okay. So what is the methods of fat removal process? So by the clarification we can remove the fat from the milk, then we can produce the skim milk powders. This is the basically here it is used. So objective of this clarification, as an alternative to filtration, clarification can also be employed to remove insoluble impurities, especially the finer ones. It involves the use of a centrifugal machine called clarifier. Thus, clarification is a process of subjecting milk to a centrifugal force in order to eliminate the finer but heavier particles from milk, somatic cells, dust particles, etc. Although part of bacteria are also removed along with the extraneous matters, clarification cannot be considered an effective means of bacterial removals. Hence, one should be aware that it cannot be a substitute for a suitable heat treatment in order to ensure safety against the pathogenic microbes. So this is the principle of clarification and operation clarifications. Principle, as we have studied, when milk is introduced between the two adjacent rotating conical discs of a centrifugal bowl, it is subjected to a centrifugal force. This force causes the heavier dirt particles to be thrown out into the sludge space surrounding the disc, where it is collected during the run, while the comparatively lighter milk continuously flows inward and upward to the outlet. Okay, so operations raw milk is made to pass usually under a pump pressures down a central pipes of a rotating boil and led to the outer edge of the clarifier disc through a distributor in the bottom and then onto a spinning disc where milk and dirt are separated. The milk is led to the discharge pot of the top of the boil, whereas the dirt are accumulated in the sedimental phase. Okay, so please see the council website where we are already uploaded the all details per person, and also you can read the books of Sukumar De, Iske De. Okay, now now you have to know what is the separations. Previously I have seen clarification and filtration process. So both are separate the basically separate milk from a like foreign particles. Okay, so we know the separation basically two types: gravity separation and centrifugal separations. Gravity separation means when you taken some milk and allowed to stand undisturbed conditions for some times. A layer of cream form on the top of due to the rising of the fat globule, which is initially dispersed through the out of the bulk of milk. The upward movement of the lighter fat globules is then heavier serum take place owing to gravity. Creaming may become evident in a short time as a half an hours. And centrifugal separation, what? In principle, this method of cream separation is similar to gravity separation, but gravity as the driving force is replaced by the centrifugal force, for which a rotational machine is used. Since the latter force is much larger than the gravitational force, separation is greatly accelerated. The centrifugal separation separator is similar to the clarifier discussed in the earlier sections, but milk entering through the bottom of the separator bowl holding a stack of conical discs rises up through holes located somewhere in the middle of the inner and outer edges of the discs. The milk between discs is subjected to a centrifugal force in the rotating boil and thereby tends to fly out from the center. The skim milk sections, being heavier, moves away and form a layer on the outer edge of the discs, where the fat globule gather on the inside edge. Okay. Now, okay, so now I have discussed another machines and my next class. Okay, so thank you everyone.